Okay, and it's done. I've been actually using this for a few weeks now, but haven't had time to make the videos, so here it is. It's my Apollo style home automation controller. It can run quite a few different programs. The only external leads are network and power, so everything else is contained in here. It actually connects to my server, which is somewhere that way below my desk, but the standard program is the clock program, which shows the date, the time, binary representation of the time. Can you actually see that? Yeah. It's a bit hard to film, but yeah. And this is the days until the Unix 2038 bug. The 31-bit overflow time. Most of the logic behind the stuff is on the server. This is mostly a display and keyboard and has only the logic to run that and the network connection. Let's take a look at some of the programs, or take a look at the keyboard first. We have some specialized keys. You have alpha, beta and gamma. These are the output displays. The one here is the input buffer, and this is basically a very low resolution graphical display. The first program I want to show you is a countdown program. It's program 0, so we say pro 0 enter, and then we can say, okay, let's have a 1 minute, or let's do a 10-second countdown. So we say alpha 10 enter, and we have a 10-second countdown. Now when the count runs out, we get an alarm, and we press arc 2 times, and we acknowledge the alarm, and it gets cancelled. We can run 3 countdowns at once. Let's say 1 minute, 10 minutes, and say 12 hours. So now this would come up, and even if you're in a different program like the clock program, I can cancel a countdown by setting it to 0. And let's do this for 10 seconds and go to the clock program. Now we're in the clock program, but the countdown still runs in the background. It switches to the to the countdown program, shows us which alarm it is. We cancel it, and it goes back to the previous program. The next program, program 1, is basically a stopwatch, but it has a... wait, forgot something. Normally you enter like, okay, say let's 10 hours, which is 10:00 for the minutes, 00 for the seconds, and we have a 10-hour countdown. So let's cancel it. But say we want a 300-second countdown. I know it's 5 minutes, so I can type 500 for 5 minutes. But I also could type 0300, so 300 seconds. The leading zero says I want to input seconds, and we get the 5-minute countdown. Okay. Program 1 is a simple stopwatch in seconds, basically an elapsed time counter which has up to 24 hours. It's a 24-hour. At 24 hours it goes back to 0, and as with the countdown program, I can just I don't need to. I can run multiples. I can run 3 different stopwatches or elapsed time counters. Yeah, I can do multiple operations before I press enter, and they get all executed at once. So if you're in, or say we're in the clock program and I want to activate 3 countdowns at once, I would say program 0, make this 5-minute countdown, so 300 seconds, make the second one a 10-hour countdown, and the last one a 10-second countdown. And it's switched over to program 0 and input all those numbers. Basically everything that's in the input buffer gets sequentially executed. So I could say, okay, cancel the first alarm, cancel the second alarm, switch to program 1 and activate the elapsed time counter. There we go. We go to program 2, which is the main home automation control. I have this is the channel which we are on, this is the device we are on, and this is the state we are on. This is actually, I think, yeah, one of the studio lights, but to show you how it works, we go to 17, which is, let me get it, this fan here. I know it doesn't really fit into the picture, but we can, let's see if I can do this. I can say gamma 1 and enter, and then the fan starts. And it switches to 1 to show it's now running. So the same goes with services on my server. So for example, I have my garden space program, like I'm currently working on the water feeler 2 probe, and the decoder is for the decoder program is running on channel 1, slot 1, and it's currently active. And say I notice it doesn't really decode, so I can either turn it off and turn it back on, or I can just ask it to restart or reset by mode 2, enter, and then it would automatically restart, and then it's running and we're online. Program 3 monitors some state of my public server. It's just an internal thing. Program 4 is my homemade climate control thingy in my bedroom. This is the temperature, this is the humidity, and we're currently in automatic mode for both. I can currently switch them separately between manual and automatic mode, but that's a bug. It currently tries to keep it in a certain range, but I can just switch off automatic. That takes a minute because it's only running every like 10 seconds or so on the server. But now let's switch on the heater, and I heard it switch on. It's in the other room, but yeah, and then a few seconds after that we get confirmation that it switched on. But let's switch it off, or also switch on the humidity, the humidifier. Humidity is already too high, but since automatic is off, it will just happily switch it on, hopefully. As I said, it takes like 10-15 seconds sometimes. Yeah, now humidifier is on. And when I switch on the automatic, it will notice that humidity is too high, I think. I'm not sure which range I put it, but it should switch off the humidifier. Yes, it did. The heater is still running because we're in the middle of the band, but I'm gonna turn it off for now. I can override this. The automatic keeps running. It would turn it automatically back on if it notices it's out of the band, but yeah. And as I said, before I go into that, this also has an infrared receiver and infrared transmitter, mostly for my ceiling fan, and so I could just, it's not running, but for a demo purpose, I could just say, okay, I want to turn it on now on power level 1. Then it transmits and it turns on, and I can turn it off again by sending another infrared command. The fun thing is, my homegrown transmitter with the Arduino inside runs better than the original infrared transmitter, the remote, because it's so much more powerful and it just works every time. We can also turn off the display if you want to and turn it back on. We also have the option of just rebooting the Raspberry Pi if it has any problems. This works. This is one of the things that even works if it lost network connection. We say program power enter, then it turns off the display, goes into an error mode, then the Raspberry Pi reboots. Come on. and it loads the state back from the server where it last was, so we get back to the program. Now, if I have to say I want to turn on the ceiling fan, the other fan, I would like have to say program 1, go to I would say power level 1, then go to program 2, channel 3, slot 17, turn on. Now typing that in every time is, well, that's a short command, but I have some stuff where I have to switch like 4 channels, 8 channels, whatever. For that, what I forgot to say is, if I type something in, I can use delete to delete the last input, or I can cancel the command with escape completely. If I go to program 9, this has 24 slots for storing and recalling scripts. So let's say we want to create a script to turn on both fans. So we go to program mode. No. There we go. Now it marks the slot we want to program with a point. We can always escape and cancel, but we want to program this. Then we say we go to program 2, which is the home automation thing. Channel 3, slot 17, turn it on. Then we send power infrared command 1 for power level 1. Enter. This is now stored. And if I want to run that, maybe I want to also program a thing to turn off both fans, so do the same thing. 10, enter. So we send power level 0, go to program 2, channel 3, slot 17, and turn everything off. Now that is also stored. So how do we turn this on? Well, you've already seen this, so I don't have to hold this thing here, but let's say we want to run program 9. Ceiling fan runs, the other fan will take some time, but yeah. And you can also run, sorry, we need to go to program 9 again. I could also program that in, that it goes back to program 9, but I forgot to do that. So let's run the shutdown program for this. Come on, sorry, 10, yes. It does that, and the fans have switched off. So that's one more thing I forgot. We can delete a program, of course. And we have also some special programs like that are mostly used for scripting, like program alpha 10. So program alpha waits a specified amount of time, like the countdown, but instead of an alarm, it stops input processing and only continues with it after the count has run out. So if you say program alpha 10, then program 10 is for 10 seconds, and then go to, say, program 2, whatever, it would run down. It has still the rest of the input in the buffer, but it waits until before it does that. Program beta would let's say program beta, program to enter. I'm not sure how that one. I used it before, but I'm not sure if I. Alright, program beta is for waiting on an input state. Right, or for a home automation state, and program gamma is for interactive, basically asking, do you want to continue? So let's say we want to switch the in program 4 switch. That's a bad example. Yeah, forget the input state matching or the automation state matching for now, but or we could actually say we want to turn off automation and turn on humidifier manually. But if you turn on the humidifier before the switching off of the automation has been processed, it might switch the humidifier back off immediately. So what we do is we make a new program, say 9. Then we go. The program is go to program 4. Switch automation off. Then we go to program alpha 10. Wait 10 seconds. And then we switch the humidifier on and go. Yes. Now that's our program 9. When we execute it, it would switch the automation off, wait 10 seconds, and then it would request switching on the humidifier, which will take some time, I think. Yeah, there it goes. Let's switch that off and switch the automation back on. And yeah, the same goes, say, delete this one. Say before switching on the ceiling fan by a script, make a new program. We want to the user to confirm before he does that, so he doesn't run the wrong script or something. So we run program gamma and then send the command to switch on the ceiling fan. Now when we run the program, it would beep and show a question mark, and if you press escape, then nothing happens. Let's run it again. this time we want to do whatever is the program does. We press enter and the ceiling fan switches on, so switch it off again. And yeah, the thing with the wait on state is a bit more complicated, so maybe I showed it in a different video. But if I have some screwdriver here, I don't. Wait a second. Okay, let's open this up. There's not all that much inside here. It's the Arduino Mega, a lot of cabling, and the Raspberry Pi. So yeah, it's mostly all the stuff is on the outside, so there's really not much inside. A lot of loose cabling and stuff, but yeah. And this isn't just like a thing I play with. Sometimes I've been actually this part is recorded quite a few weeks after I started assembly, and I've been using this device constantly. I switch my studio lights, I switch my heating, I monitor system services. When I test stuff for the Garden Space program, this is how I switch the modem services, decoder services, all that stuff. I have this on the side of my normal keyboard, so if this were my keyboard, this is on the side, and I can just quickly type the numbers in, press enter, and I don't have to go on my server and switch stuff. It's just always there, and it's just very easy to use. And you may ask, why does it look a bit funny where the numbers are? That's I have some plastic, and I have a big piece of transparent plastic and some of this electrical tape thingamajig on top to make it look more retro. And yeah, that's it basically. Thanks for watching.